polynomial. I will identify odd and even functions. I will describe the end behavior of functions, and I will evaluate functions. We've been working with functions, with parent functions, with horizontal shifts, vertical shifts, vertical expansions, compressions, axis of symmetry, vertex change, things like that. We're going to continue this. Okay, now before we can, what is a polynomial? Okay, if you Google it, you're going to get something like this. A polynomial is defined as an expression which is composed of variables and constants. Variables are our unknowns, constants are our numbers. And exponents, they're combined using mathematical operations such as addition, subtraction, multiplication, and division. However, the kicker is no division operation by a variable. This means to have a polynomial, the variable cannot be in the denominator. So if you see something, I don't know, like 3x squared plus 1 over x minus 5. This is not a polynomial, whereas 3x squared minus 1, that would be a polynomial. Okay, our variables cannot be in the denominator and still have a polynomial. Now, with that said, I'm going to run over there. I just grabbed a quick PDF, and what we're going to do with this PDF is we're going to talk about proper form. Now, proper form, and in this in particular worksheet, they call it standard form. We're going to call it proper form. Okay, I'm going to start with number 3. All right. Now, the thing about it is, now number 3 has us to do a little something. Sometimes we have to perform operations, sometimes we don't. We're going to go ahead and simplify this. Now, as you see, this 2 is outside the parentheses, so the 2 has to be distributed, multiplied into, so 2 times this and 2 times the negative x. Okay, so a negative 2 times 7x cubed is a negative 14x cubed. A negative 2 times a negative x is a positive 2x. And then that negative 2 is not distributed to this negative 9x to the 4th. So I have my negative 9x to the 4th. Okay, so we've kind of simplified it, but we're not finished because it's not in proper form. Proper form is we take the term with the highest exponent and list it highest exponent to lowest exponent. So if we step back, the highest exponent is x to the 4th. But we have a negative 9x to the 4th. That's one term. So this is negative 9x to the 4th. Whoops, that looks like a y. Not really sure what happened there. 4th. And then the next, after 4 comes a 3. If we have a 3, we need a cube, then we need to put it. This is a negative 14x cubed, keeping the signs with the numbers. And then we have a positive 2x. Now, this polynomial is in proper form, highest exponent to lowest exponent. So we've done our first I will statement. I will write a polynomial in proper form. That is proper form. The green is. Now, once we have written it in proper form, the degree and the leading coefficient is easy. The degree, look up there. What's the highest exponent? 4. So this particular polynomial has a degree of 4. So the degree is 4. Now, the leading coefficient. What's the coefficient of the term with the highest exponent? Negative 9. Okay, so my leading coefficient is negative 9. Okay, and the degree, I'm going to put it is 4. The degree is 4. So, write it in proper form, identify the degree, identify the leading coefficient. We will talk about odd and even functions later, and we will also discuss the end behavior on those odd and even functions as well as evaluating functions. We're going to take a little bit at a time. But all of this is getting familiar and getting us to begin to work with functions in more than just a way of identifying what family that they would belong to. Okay? Now, after we go to 3, let's go to 7. Okay? 7, I don't have to do any distributive work at all. All I have to do is rearrange terms from highest exponent to lowest exponent. My highest exponent is a cube. I have x cubed. I have a positive 11 with the x cubed. So I'm going to write this in blue. So I have 11x cubed. After x cubed comes x squared or x. I do have an x squared. I have a negative 10x squared, keeping the signs with the number. And then I have a negative x. And if I had a constant, the constant would be tacked on the back. Not a big deal. So this is now in proper form, highest exponent to lowest exponent. So now all I have to do is identify the degree. The degree is easy. 3 was the degree. The degree is 3. Leading coefficient, the number in front of my variable with the highest exponent. Okay, the degree is 3. My leading coefficient is my leading coefficient is 11. Okay, so quick, simple, easy, not too bad at all. Let's see, I'm going to run over, I'm going to erase this, I'm going to go on over to number 4. We're going to look at it right quick, and then actually we will be done for today. Okay, so I'm just going to look at number 4 real quick. Again, my goal is to put it in proper form, highest exponent to lowest exponent. The highest exponent here is an x cubed. Okay, 24 is the coefficient of my x cubed. So right here, I have 24x cubed. Then x cubed, I got an x squared, maybe an x, but I have an x squared. Negative 20 is with it. Negative 20x squared. I don't have any x's, and that's okay, but I have a constant all by itself, minus 2. So this polynomial is now in proper form, highest exponent to lowest exponents. Identify the degree. The degree of this polynomial is going to be 3. So my degree is 3. And my leading coefficient is a positive 24. So my leading coefficient, E-F-F-I-C-I-E-N-T, is 24. Again, quick, simple, and easy. So be sure that you have all your I will statements in your journals, and be sure to complete your questions for the day. Thank you.